So now we'll move on to Andrew Felton. And Andrew is a plant ecologist who focuses on grassland, rangeland, and dryland ecosystems. He earned his PhD in 2018 at Colorado State University and is currently a postdoctoral research associate at Utah State University. He's interested in using different tools and data sets to better understand and project how water-limited ecosystems, such as rangelands, will respond to changes in water availability associated with climate change.
So thanks, Emily and Maud, for putting this together, and thanks, everybody, for your time and attention. I know both are extremely valuable. So what I'll be showing you is kind of a continuation of that equation that Peter showed, and we'll be here combining forage sensitivity with John's exposure data to focus on kind of the big picture of what we're expecting to see in terms of changes to forage availability across the western U.S. And I'd like to start with just a brief overview of our approach. So what we did is we used historical satellite-based data of forage production along with weather data that John described to build ecoregion specific models of forage sensitivity to temperature and precipitation over roughly the last 30 years. And just to show a schematic of how that works, so if you consider a single site, you'll have long-term variability in above ground productivity, along with temporal variability in the key weather variable that you may care about, such as growing season precipitation. And so what we did is we focused on these types of historical relationships, and built these historical temporal statistical models, and we used these historical data for temperature and precipitation. We did this for each of these different ecoregions. So we had ecoregion specific models focusing on these historical relationships. Because as you may imagine, there may be different time periods that these systems respond to weather. And this historical approach builds the sensitivity portion of that equation. And then when we have those ecoregion specific models, we can feed John's projections through those models. And we use 11 different climate models to project how forage production may change by mid-century. And as I mentioned a brief second ago, we focused on growing season weather for those 3 to 6 months time periods where forage may be most responsive to variation in weather. And at the bottom left there, you'll see the citation for the remotely sense-based data set that we used. And this data set with innovations in how we can partition reflectance signals from pixels, we're able to extract and partition herbaceous productivity from these pixels. And so we use that to represent forage productivity. And just a brief, just to give a nod to some of the limitations. So these models are based off the historical relationships between forage production and weather. And we're extrapolating those relationships into the future. And so this contrasts with more a different approach that other people use with process-based models that actually simulate a whole suite of ecosystem processes. And this potentially makes our projections a little more pessimistic because they do not explicitly include physiological processes such as CO2 fertilization, which is presumably could lead to increases in forage productivity through increasing how efficiently forage or plant growth uses water availability. So that may make our projections a little more biased with not being able to include that. And what I'm going to show you is going to focus on the big picture of the entire West and really building on Peter's reframing of where climate change impacts will be the greatest. So what I'm going to show you are percent changes from the historical baselines. And I'm going to show you both percent changes in average forage production, focusing on that high emission scenario, and percent changes in the probability of years of low forage production, which we defined as years in which forage dipped below 75% of that historical baseline mean, or greater than 25% reductions. And I just stumbled upon a brand new paper that has some similar analyses or approaches as we did, and they use the same approach to quantify bad years. So that's what did the asterisks for. And these maps I'm going to show you are aggregations to the county level. So we have our per pixel projections, and then what I did is I averaged according to the counties in which those pixels were embedded. So just keep that in mind, that is a way that we've decided, at least right here, to aggregate the projections. We love some feedback on whether that is or is not useful. And so let's just jump into the big picture here. So let's focus on first that left side map. And this shows the average percent change in forage production by mid-century. And if you look at the color gradient at the top there, the light blue, that's a positive. The blue indicates a positive change in forage production. And then as we go down to that dark red there, we get quite negative percent reductions in forage production. So as you can see, if we start off in California and then move east, for a lot of the regions, we see relatively small projected changes in average forage production by mid-century. In California, annuals are even slightly positive. As we move towards the Great Basin into the northern plains, those are still relatively smaller changes in average forage production. But if you focus on the southwest there, particularly in Arizona and those hot deserts there, we start to see larger changes in average forage production. Okay, so getting at the idea of where these changes may be greatest. And if we go to the right here, we have the average percent change in the probability of a bad year. And in this case, the dark red shows large changes in the probability of bad year. So red is similar to that. And we see somewhat similar signals as we've seen average changes. The California actual is projected to see decreases in the frequency of those bad years. Similar with the Great Basin, we see small changes. But as we go into the southwest, as well as the southern plains there, we see potentially large changes by mid-century in those years of low forage production. So if we get rid of the states and just focus on the western U.S., we can delineate these changes by ecoregion. So again, this is average percent change in the probability of those bad years. So the signal shows hot deserts and the short grass steppe or the southern plains as being areas that are potentially quite vulnerable to climate change. But if you go into that transition zone there, the northern plains and southern plains there, we also see potentially some larger changes in percent in the probability of those bad years. And I just want to use the northern mixed grass prairies there because we see a lot of spatial variability in those projections as a way to give you a sense of the degree of uncertainty among these RCP projections and climate models. So the map here shows the whole northern mixed grass prairies ecoregion for percent changes in average forage production. And on the right here shows the spread of the 11 different climate models for both the low emission scenario and the high emission scenario by mid-century. As you can see that in general, the box plots are geared towards relatively small changes in forage production. On the y-axis, there is actually in grams per meter squared. You can see as we go into a higher emission scenario that spread gets a little smaller. But I just wanted to give you a sense of the uncertainty among the climate models for the most, arguably the most variable. So in that, we can't go into the future and validate these projections, but what we can do is put our projections in the context of what other people have found doing a similar approach to us. So how do these projections compare to previous studies that sought to, that had a similar goal of projecting forage into the future, climate change? And I'm going to go through the different ecoregions here now. So if we focus on the Great Basin, the previous studies that have come out have shown either positive changes in forage production or really neutral or no changes in forage production. How that matches up with our work is that we're seeing small reductions or really no changes, that neutral, I guess, changes in forage production. So mostly this aligns with what we're seeing in that perhaps climate change is not a huge or may not be a huge priority in this region, at least relative to the other ecoregions we've looked at. We move to the California annuals. Previous studies have shown similarly that forage production is projected to increase across this century. And that also aligns with what we've shown. The not quite there should be yes. I guess I forgot to change that. And is climate change perhaps a large priority relative to the other ecoregions we looked at? Perhaps no. We go to the northern plains. Previous studies have shown either increases in forage production or neutral changes. And what we've shown is that we're seeing reductions or really neutral changes in forage production. This somewhat aligns with what we've shown, and perhaps you don't need to prioritize climate change in that ecoregion. But as we go to the southwest and the southern plains, there is a consistent signal of fairly large changes and reductions in forage production in previous studies that aligns with what we've shown. So relative to the other regions we've looked at, climate change may need to be something that's prioritized as we look towards the future. To summarize here, seeing relatively smaller changes to forage production by mid-century for many of the ecoregions, the northern plains, Great Basin, and California annual rangelands. We compare that to the southern plains in the southwestern U.S. That may be more of an area where we see larger changes to forage production, and that where climate change may need to be a relatively higher priority. This leads to one of the conclusions that the southwest and the southern plains rangelands appear to be particularly vulnerable regions to future climate change. And I'll end on a quote that I like by a paper from Matt Reeves a few years ago, who did a similar study as us, that multiple indicators point toward increasing vulnerability of cattle production in southwestern regions, providing strong support for the need for adaptation measures, and suggest significant changes to the industry. And our general findings here of the Southwest and Southern Plains, seeing large changes in forage production there, aligns with this quote and supports previous findings. And I'll stop there. Thanks.
Thanks, Andrew. I really appreciated that table at the end to compare with other studies. Any questions for Andrew about productivity across these different regions? Please go ahead and enter them in the chat or unmute yourself. We have some time.
Emily, I have a question for Andrew. This is Danelle.
Yeah, go ahead, Danelle. Thanks.
Okay, great. Andrew, I'm really interested, as an ag economist, really interested in the increase in the probability of bad years in the northern plains where I work. And so I'm curious whether either the probability of good years or the extent, quality of good years, I'm wondering how the opposite end of the spectrum might be affected by climate change. And what I'm really thinking about is, will the good years still be able to outweigh this increased probability of bad years? And again, I'm kind of thinking about from an economic perspective, but did you guys look at all at the other end of the spectrum, kind of the good news?
Yeah, we didn't look at that, but that's certainly something that we could look at. It's just a matter of adding something to our existing code or analyses. So we did not explicitly look at that. I guess we're focusing more on the doom and gloom side here. That's an interesting question. I will say that, so I was just, that paper that I mentioned earlier by Matt Reeves, did look at that. They looked at 25%, reductions as well as 25% increases. So they did look at exactly at what you're interested in looking at. And there is a bit of conflicting results with us, where we show in the southern portion of the northern prairies that you may see an increase in the probability of those bad years. But Matt Reeves' work, which just came out, suggested that you would also see an increase in probability of those good years. So, based off what that study has shown, that suggests that that's something that we should take a look at to see if there's asymmetry or symmetry in those good or bad years. So that's a great point.
Yeah, thanks, Andrew. A lot of the ranchers in our region tend to manage for the middle. They tend to manage for the average, and just general observation that the average is becoming less and less difficult. It happens less and less often, and instead you're getting, more on each end of the spectrum. And so a need for more flexible grazing management. Thanks for your answer.
Absolutely.
And thanks, Danelle. And I see in the chat box, Retta Brugger has put a question the question in the chat box. Retta, did you want to speak your question, or do you want me to read it?
Oh, I can speak my question.
Great.
So I'm in Western Colorado, and I'm an extension agent serving the Western region of Colorado. So I've also talked to some other folks about this, but noticing in many of the maps we've seen today that the mountains are omitted, or mountainous areas, and there may be, obvious limitations for why that is. But as somebody working with cattle producers here, those mountains are really important sources of forage. So just curious about what other types of products are available, and maybe even the challenges of predicting forage in those particular areas.
Yeah. In terms of products, the data we're using is from a remote sense product that's targeted specifically for rangelands of the western U.S. So I don't exactly know if that the coverage of the data has those mountainous regions. That was something that we were kind of worried about in terms of if we had the 6 kilometer pixels over mountainous regions, would we be capturing also areas that were not rangelands? So we took a conservative approach to filtering out data that more focused on the plains regions, I guess. So in terms of data products, I don't have a great answer for you, and maybe somebody else would. But for trying to look at specific regions or specific counties or areas, it could be possible if the coverage of the Forage data we have includes that, and if this would have to be perhaps a more site-specific collaboration with you or others. There's a specific county or even like pixel or a few pixels that we could hone in on. So I'll let anybody else speak to other data products, but that is certainly something I could try to follow up with you if the data product that we use prior to our filtering had the coverage of some of those mountainous areas that you're interested in. But I'll just say from our perspective, we were concerned about having these 6 kilometer pixels maybe capture non-rangeline areas, so we opted for a fairly conservative filtering approach.
I'll add to that. The other issue beyond do we have the remote sensing data on productivity, which I think is the whole continental U.S., so I think that would be there. Remember, we're correlating production with weather, and I'd be more worried about the weather data for those mountainous regions. When we don't, if we're trying to get weather for an area that doesn't have nearby weather stations, then we're relying on interpolations, and they have a hard time with topography. You probably know about the PRISM product, comes out of Oregon State. It incorporates, it considers topography, but it gets harder. I think that what we're calling the cold deserts is based on a map of potential natural vegetation, and it will include sagebrush steppe areas that go up into the mountains. But if you're talking about, say, tall forb communities or subalpine meadows, we don't have that. And I don't know how, like Andrew was saying, even if we can get the production data, I'd be worried that we don't have good weather data.
Emily, this is Joel Brown. I'd like to ask a question of all the presenters so far.
Go ahead, Joel.
Nice job on the predictions. A question that I get frequently, and I have, is can we take these models and decompose them even further, say at the ranch level or something like that, or ecological site level, and come up with some predictions that we could actually use at the ranch or multiple ranch, maybe watershed scale or something like that, rather than, can we go a step lower than county? And, what kind of uncertainties would that bring into it?
Yeah, maybe I'll take a stab at that one. So the reason we aggregated to county level is because we didn't want people to focus on individual pixels. The statistical models we're fitting are capturing the trends across the whole region. They do, to the extent that precipitation and temperature, independent variables vary, they will capture variation in the response related to those. But no, I really don't think it's appropriate to use these models to drill down to a very specific area. And so we really want people to squint at the maps we're showing and just look at the broad patterns there and not try and get too specific spatially. There's so much uncertainty in these that it seems inappropriate to think that you can say something informative about one particular location. So yeah, we're really more focused on the region. That's a great question. Thanks for asking.